Hello students, and welcome to the final module for your AP Calculus course. In this lesson, we're going to start learning about the second fundamental theorem of calculus, or the fundamental theorem of calculus part 2. So let's get started. So what the second fundamental theorem of calculus is going to work with is going to be specifically for functions defined by integrals. Things like, okay, I have a function and it's going to be equal to an integral from a value to x, or there could be an additional function. Instead of 1 to x, it could be 1 to x squared or something like that. And so let's start by finding f of x and f prime of x, and we're going to start to kind of get some ideas about the second fundamental theorem of calculus. All right, so I see that f of t is 4t minus t squared. I'm going to take f of x and we're going to figure out what is f of x here. Well, this is going to be the integral from 1 to x of f of t, which is 4t minus t squared dt. All right, so I'm going to need the antiderivative and then I could go from there. So let's say, okay, f of x. So what is that antiderivative? Well, this is going to get me 2t squared minus t cubed over 3. And what I want to do is I want to evaluate this from 1 to x. So notice here nothing has changed, okay? So then I'm going to substitute in my values just like we have been doing. So I'm going to get 2x squared minus x cubed over 3. And then my lower bound is going to be minus 2 times 1 squared minus 1 cubed over 3. Okay, so what is the result that I get from this? So let me just kind of write it out first. So 2x squared minus x cubed over 3 minus 2 minus 1/3, so that's going to be minus 5/3. All right, so this is f of x. We also want to figure out, all right, what is f prime of x going to be? Well, that's just going to be 4x, and I'll bring the 3 down, so that's going to be 3x squared divided by 3, so that's going to be minus x squared. What I want you to take a note is, notice how f prime is equal to f of t here. So kind of works out. So since this isn't anything really new, I want you guys to go ahead and work on number 2, doing the exact same thing. All right, so this one is finished. And what, again, I want you to notice is, okay, we figure out what f of x is. That's pretty straightforward. You just substitute in the values, just going through, finding derivatives like we've been doing. And then f prime, again, is coming out to the original function, just cosine of x now instead of cosine of t. So what I want us to do now is take a look at this, is when, instead of going from 1 to x, what if we went from 1 to x squared? Let's find f of x and f prime of x for both of these problems. Okay, so that's going to be both of the problems here. So in our first one, what I did was find my antiderivative, substitute in x squared and 1 using that fundamental theorem of calculus that we've already learned about. And then took the derivative, so x to the 8th over 4, bring the 8 down, subtract 1, and simplifying it, I got 2x to the 7th for that derivative. And then for that problem on the right, the exact same thing. There was some simplification, of course, because I didn't want to screw up on the square root. But x squared to the 3/2, of course, you're going to multiply those, so you get x cubed, 4 times x cubed minus 4, and that's going to be our function, f of x. Then the derivative of that, bring the 3 down, multiply it, you get 12, subtract 1, 12x squared. What I want you guys to see, is there some sort of pattern? Because before, when we were looking at our other problems, they were coming out to exactly what is above, right? So I had 4x minus x squared, 4t minus t squared. I had cosine t, I had cosine x. Now, is that the exact same pattern? No, it's not the exact same pattern here. I'm getting 2x to the 7th and I started with 2 cubed. What is specifically happening here? See if you can find a sort of pattern, but we're gonna get into now, all right, here is the second fundamental theorem of calculus. So what we're looking at are composite functions. If you have a function defined by an integral and you want to find the derivative, all you're going to do when you're finding the derivative of your function is you're going to substitute in whatever that upper bound is. If it's to x squared, if it's to x cubed, 2x to the fourth, whatever, you're going to substitute that into the function that's inside the integral, the integrand, and you're going to multiply by the derivative of that boundary. So again, basically what you're doing is whatever that function is in the for that limit of integration, you're going to take that, you're going to substitute that in, and then you're going to still, that's exactly what happens here, and then you're going to multiply by the derivative of that upper boundary. So that's exactly what's happening here, but we're going to go into more depth with it, more practice with this specifically in our next video. So stay tuned for that. Of course, if you need help understanding where we got some of these derivatives from, definitely check out some previous videos, but you can also come directly to me and ask any questions. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.